Hey everyone, this is Mr. Z and welcome to this tutorial where we're going to set up a 4x4 keypad with an Arduino Uno Rev 3. Now hopefully you've had some familiarity working with the Arduino Unos. If you haven't, I recommend checking one of my earlier tutorials. But to begin, the keypad has 8 pin ports on it, and those each need to get plugged into a digital port on your Arduino Uno. Now the ones I plugged mine into based on this schematic over here and looking at this code, starting with the first one, that's the one where this yellow wire is going to. I have that plugged into digital 2, so it's right over there, digital 2. Then the next one is plugged in digital 3, then digital 4, then digital 5, based on that line over there. So you want to plug those first 4 wires based on this code over here. Then the other 4, even though I could have continued on and plugged it into digital 6, digital 7, digital 8, and digital 9, instead what I did is I decided to use the analog ports as digital ports, which you can do. It's just usually you don't need to do that because you have 13 digital ports, but later on I'm going to add in an LCD, and I want to save some of my digital ports for that LCD, so I don't want to consume them all with the keypad. So starting with that 5th wire, which I have this blue plugged into right here, that is going to A3, and then A2 for the second wire, and then A1 for the green wire, and then the last wire is going to A0. Now, if you look at the code, I have over here saying they're plugged into 17, 16, 15, and 14. And just to explain why they represent those things, our digital ports here go from 0 to 13, or 0 to 13. And then after port number 13, we can technically call port A0 on this side port 14. And then the one A1 is technically port 15. So we can do that to add on additional digital ports using the analog ports, and they'll work just the same for most applications. So go ahead, plug those in, and then let's take a look at this code and let me break it down for you so that it not only is hooked up correctly, but it also makes sense as well. Okay, and we are now in the code part. So I do want to warn you ahead of time that I'm going to go through this very thoroughly, because I could go through it quickly and try to explain it really quickly, but I'm going to do a terrible job if I do so. So I'm just going to break it down, and if you need to skip ahead, I completely understand. But to begin, we're going to use the Keypad.h library, because the keypad over here, right now, the Arduino program itself doesn't understand what a keypad is. So by using this library file over here, the Arduino will understand what it is and allow it to function correctly with the Arduino board. We're going to skip this next line for now, but we're going to jump down to these next values here. As I mentioned before, this is a calculator. A calculator needs the ability to store a first number, a second number, and then add those numbers up. Because we're just going to be working with integer values for what we type in, the first number is going to be a long type variable. Longs are just integer numbers that can go up to like 64 places or so. So whatever your first number is, as long as it's 64 positions or less, you should be okay. I believe that's the case. It might be less, it might be more, but that should be a rough explanation of that. Same with the second number. It can be a very long integer-based value, and the calculator will store that. Now the total, depending on what action you're doing, like let's say you're dividing two numbers together, could potentially be a fraction, not a fraction, a decimal. And because it can be a decimal, we want to use the double type for that, because doubles will allow you to have decimal positions and create floats and whatnot. So that's why the total is the way it is. Okay, so whatever values we get, we're going to store them into these words. Okay, this code over here is all about setting up the keypad. Okay, we are calling our keypad custom key. Okay, it's a character type of keypad. which means that all these values in here are characters. You might have noticed that we're not just using the number 1 or the number 2. We're using each number, and then we're just putting a single quote around each one. So this isn't actually the number 1. This is actually a different number, but I'll talk to you about that in just a little bit. Okay, we're also initializing rows and columns with the value of 3. Okay, so each of these has a value of 3, and we're storing these. These are just simple byte files, so it's just a really like simple number. It's like the smallest variable type you can have. But we're going to use these to essentially help channel through our array. So every time you press a button on this keypad, it sends a signal through the wires. And out of these 8 wires, 2 of them will always be considered high, and all the other 6 will be like low. So 2 of them will be on, 6 will be off, and based on the 2 that are on, it will understand which value you're clicking on the keypad. And it's going to then, because we've set this up as rows and columns, we can then take that value with this line here and essentially call on it. So based on the rows and columns. So let me kind of explain that better. Let's say I press the number 5. When I press the number 5, the board is going to send those 2 high signals, or the keypad's going to send 2 high signals to the board, and the board is going to register 1 for rows and 1 for columns. Okay? And I know that because I've tested a lot. And if I open up some cheap paint file, we're starting at 0. This is a representation of the keypad. Starting at 0, going to 1, 2, 3 for the rows, and 0, 1, 2, 3 for the column. If that signal it sent was 1, 1, 1 for the rows, 1 for the columns, that is number 5. So the board is going to understand that 5 was pressed. Now if I pressed 9, I could tell you that it's going to use one of the row values of 2 and the other one of 2, and it will press that. So between the values of 0 and 3, you're essentially able to hit any value on the board. Okay, and we just need a way to store that to understand how it's working, hence why we use this code over here. So that's probably the trickiest part to understand, and I recommend just like experimenting with stuff and just seeing how it goes. And this is where we plugged in our pins, but I think I already kind of explained that a little bit already. Okay, moving down to our setup, this here sets up the serial monitor. Because we don't have an LCD on our computer, this will just set it up so that when we go to Tools, Serial Monitor, we'll get a display that will essentially display the values that we are typing. Okay, and then I do want to get into the loop, but I think I'm going to do that after. I'm going to do that now. I'm going to start that now. Okay, and then we're going to enter our loop. Okay, so the first line here just says like, hey, whatever value we type into our keypad, I want you to take that and store it in the word custom key. Okay, and then we're going to go into a series of cases. The case that we go into is dependent on what key we pressed. So if we press anything between 0 and 9, we're going to enter this first case over here. Okay, and this first case is essentially just going to take whatever value we pressed in, and it's going to store it, and then it's going to also print it out using this line over here. So you might be wondering, like, let's say if I pressed 1, why is first not equal to 1 or something like that? Why isn't it just equal to, or maybe not even 1, why isn't it equal to like custom key? Because we pressed 1. So shouldn't it just store 1 into first? And the reason why we have to use this like elaborate equation over here is because it's not actually storing in 1. It's storing the character 1. And the character 1 does not equal 1. So if I pulled up an ASCII 2 chart, okay, these are just different characters using that Arduino program we have. And if we look for the value 1, the character value of 1, here it is, it's actually equal to 49. And the value of 0 is equal to 48, and the value of 2 is equal to 50. So we can't store the value of 1 because it's not 1, it's 49. So let's say we did press 1, and the board sends the value of 49, or the keypad sends the value of 49 to the board. Then we got to take that value of 49 and convert it to 1. So over here for custom key, I want you to think of that as 49. Okay? And then we said minus 0. But you'd be like, wait, 49 minus 0 is 49, so that's useless. But this isn't 0. This is the character 0, which if you take a look at that chart again, it's not actually 0, it's 48. So 49 minus 48 is actually 1. So that's pretty nifty. Okay, so it's actually 1, and then for the first time you run this, first is equal to 0. Okay, because we said at the top here, first is equal to 0. So the first time this runs, if I replace this with 0 for first, whoops. Okay, 0 times 10 is 0, plus whatever's in here is 1, so first is equal to 1. And that's, hey, that's pretty useful, okay? But let's say I then wanted to type in another number. Let's say I wanted to type in 3, okay? And we're going to just jump back to this equation, okay? I type in 3, so custom key would be 3. Or it wouldn't actually be 3, it'd be 49, 50, 51. It'd be 51 minus 48. So that would be actually 3. And then first isn't actually 1, right? Or first is 1 from the last time we ran it. So first is 1. So 1 times 10 is 10, plus 3 is 13. So when it runs, you know, it's like we actually typed it in. You know, what's the first number of 13? It's 1, because that's what we first typed in. But if we wanted to keep going, we could do 3. And then if we kept going, we could do 5 or 6 or 4. Okay, and we could keep building up our first number, and it works the exact same way for the second number until we start a case that's plus, minus, divide, or multiply. Okay, so that's what this line is doing, and it's just simply printing it out each time. Okay, if you're still into this and you still want to go a little bit further to grasp the entirety of the code, I will see you in the second part of this video. Peace.